Hi, I'm Dave Duggal, the founder and CEO of EnterpriseWeb. I'm glad to be here with you today at CDW21 to present my talk, One Graph to Bind Them All, Linking Data and Apps for Event-Driven Interoperability and Automation. And I'll start by saying that One Graph to Bind Them All is a bit of clickbait, and I hope it brought you to this meeting and created some curiosity. But I want to set the record straight. I'm not here to talk about a new form of centralized monolith. I'm not here to tell you to burn down your legacy systems. What I am here to do is to propose that graph is actually an ideal way to coordinate end-to-end processes in a distributed system in a way that traditional middleware and even cloud-native tools are not capable of. So let's start. So the problem statement we're going to address today, it might be a little bit different than some of the other talks at CDW. We're going to focus today on business operations. And I think it's fair to say that today, the world is increasingly dynamic, distributed, and diverse. Business operations are increasingly fragmented. It's difficult for businesses, organizations to coordinate across business silos, cloud hosts, and ecosystem partners. I don't think these are news flashes for anybody. I think this is a general experience. And again, graphs are well suited for describing complex real-world relationships. I think everyone at CDW already recognizes that. But their use has been generally limited to visualization, analysis, and interoperability of data. What we're going to explore is the use of graphs to integrate data, applications, services, cloud hosts, networks, and physical devices. To essentially not just look at data and properties, look at data and functions, to look at data and behaviors. So we're going to look at building information systems using graphs, entirely out of graphs. So my company, our company's no-code platform, essentially makes it easy for customers to rapidly model complex distributed operational domains as a graph knowledge base, an enterprise web. The scope is a bit bigger than what you might think of as a data fabric or a data mesh or virtualization of data that many of you are going to be familiar with. Here, we're talking about an umbrella abstraction that provides a unified interface for weaving distributed data and functions into a logical view with aggregated system-wide entities, the index catalog of type domain objects. So a broader scope, a complete scope, actually, that allows us to use graphs with data and functions to generate highly contextual processes and services. So my thesis is that businesses need an enterprise web, a single source of truth across a complex distributed system. And what we're talking about here is a graph that helps organizations bring order to increasingly fragmented operations, higher level model, higher level abstraction. And this way they can leverage shared metadata, relationships, and state to not just drive human and system discovery, but also declarative composition, intelligent orchestration, closed-loop automation, and policy-based management. So just think about how powerful a system would be if you actually had one pool of metadata and relationships implemented in a cloud-native way that's fully distributable. So it's not centralized, it's not monolithic, it's fully distributable, and then you can actually have common pools of metadata and relationships and state information to manage your operations. It would allow you to personalize customer experiences. It would allow you to synchronize your operations and optimize your business transactions. So at the heart of Enterprise Web is our patented language. It's called the Graph Object and Action Language, or GOAL. And it is a common machine-readable language for normalizing heterogeneous solution elements. And this is really the fundamental problem of the 21st century, at least this relates to software. But actually, since software is eating the world and everybody wants to be a digital business, it really applies to almost everyone, is how do they connect their disparate systems, their disparate and distributed systems that are also changing very rapidly, evolving very rapidly. How do they manage? How do they work across that? How do they connect across silos? How do they connect ecosystem partners? How do they work across clouds? How do you work across this very fragmented environment where different endpoints are using different protocols and different formats and different schemas? And the answer really is high-level abstraction. You need to rise above this. So our language provides a graph data structure for mapping properties, behaviors, dependencies, and constraints to of solution elements to a graph knowledge base. So we're talking about a very rich graph beyond data types. It's also functional types, which makes our language goal more than just a modeling tool, a domain modeling capability. It's a domain language, a DSL. We're also going to be modeling interfaces so that we can manage interoperability, configuration language so we can connect and configure distributed applications, and a workflow language so that we can actually use graphs to actually describe sets of tasks that are very dynamic, that they have relationships and they bind on events and policies. So we're talking about a single language that's a DSL, an IDL, a CDL, and a WDL in one. My picture there is blocking that. So this is the conceptual architecture of enterprise web. We start with an upper ontology of system concepts and types, right? And enterprise web presents customers with a baseline model that already understands, generic enterprise concepts and IT and cloud type or system types. And so we give that to everybody out of the box, right? We understand what people are and units are and facilities and locations and various aspects of the typical enterprise operation. We also, of course, understand, what protocols are and formats are and types are so that we can manage those as well. Then we have an ability for customers to model their own domain as a graph knowledge base. And here what we're talking about is a knowledge base that not just describes their environment, but connects it to this higher level upper ontology, which includes the types so they can actually generate implementations out of them. They can generate full-blown interfaces out of them. They can actually connect processes, can expose services using this system. So now we're talking about a graph knowledge base to model the domain connected to a rich system, a description of distributed systems. And then at the bottom of this is a catalog of objects, the objects of the domain, right? So you model your domain and then you have objects of your domain. These are actually the solution elements that are relevant to a particular customer. And it might be applications, artifacts, systems, services, databases, and devices. It doesn't really matter what they are. It's the things that matter to that business that they need to connect. And we make it easier for them to do that as well. So we're talking about a graph approach to all three layers, upper ontology to the graph knowledge base, to also describing objects as essentially abstract data types, as objects with relationships, concepts, types, and policies, which essentially map them back up to the domain, then in turn up to the upper ontology. So, but having a single language means that this can be highly efficient, because at the end of the day, an object is a solution element that's mapped to the graph knowledge base, which is also a graph, which is also mapped up to the upper ontology, which is also a graph, which means that the whole thing is just a function of graph processing. And we essentially have one approach to graph processing the whole thing. That means we can do very efficient, real-time, contextual processes, where it might be much more difficult to do that given the latency working with cloud-native tool chains and middleware stacks. So to get into that a little bit deeper, for modeling the operational domain, first, like I said, we give you a baseline model out of the box. It includes generic enterprise concepts and types. It's fully inspectable and extensible. Then customers can actually they can jumpstart their modeling by importing a model. They can have XML, RDF, JSON, etc. They can even give us pseudo UML that might be in a Word document or a PDF document. And we can import those to algorithmic entity extraction and map those to concepts in our upper ontology to essentially seed the graph knowledge base. And we do that in seconds. Then from there, solution architects can continue by manually curating the graph knowledge base, right? They can tune it, they can extend it, they can modify it as need be for their operational domain. And another way they get model information into the system is actually by onboarding solution elements themselves, because as you onboard more elements and as your use cases expand, you're effectively going to be expanding your domain as well, right? So that leads to this grow as you go concept, because everything is done in graphs. Graphs are optimally situated not only for flexibly modeling relationships, but with graph, we all know that graphs can actually be modified much more easily in static hierarchical models, right? They're easier to evolve over time. In enterprise web, everything also happens to be immutable. So we version control everything. We're actually version controlling the objects in the catalog. We're version controlling the graph knowledge base. We're also version controlling the upper ontology as we put out new releases. So everything's version controlled. Everything has audit history. And this all allows you to essentially model. You start with maybe a narrow use case, implement that, and as you succeed, expand the use case, add more use cases, and evolve with your domain. These are all challenges in a hard-coded world that I think many of you probably recognize. So when we get a little bit deeper into object modeling itself, now we're actually talking about how we onboard a singular, it's an application, maybe it's a service, maybe we want to onboard. We actually already have. We give customers a catalog of a couple hundred existing objects, like the mappings to Amazon Cloud or Google Cloud, et cetera. We have mappings for a lot of common, cloud native tools, and et cetera. Kafka, MariaDB, other things like that, all out of the box. But customers can also model their own solution elements. And essentially, what they're going to do is, whether it's a code package, it could be an application, a function, an algorithm, or it could be a third-party orchestrator, a controller, a system, a database. We can model adapters using Enterprise Web. Or if it's an endpoint, like an actual service that somebody wants to model. All of those can be modeled in Enterprise Web. Essentially, they're going to become typed objects. And the method is effectively the same. Essentially, there's an interactive API or a dynamic form. When you're looking to onboard something, the system is essentially going to present you with effectively either a UI-driven wizard or an interactive API that's going to look for you to enter information that's going to essentially progressively type the object, the solution element that you're looking to onboard. And as you do that, the system's going to be, the type system is going to be interacting with the graph knowledge base and the upper ontology to autofill properties and behaviors that the system already knows, because the presumption is the graph knowledge base is in place, the upper ontology is already in place. So we already know a lot of things about this domain. So we know a lot of things about different kinds of types. So we can autofill the properties and generate very rich interfaces. So taking things that might, onboarding things that might have taken days or weeks, we can, even really complex things, and we can do it in minutes to hours. So we're really trying to simplify the modeling exercise itself at the graph knowledge base level, as well as at the onboarding level as well. Everything, like I said, is persisted in a backing store, and it's an immutable log style append-only storage. It's cloud native in its nature, right? All the objects in Enterprise Web are dynamically indexed, tagged, and version controlled. So all those things are just done as in the background for the customers. They don't have to worry about those concepts. Essentially, we're abstracting storage from them. So we're also providing a process that facilitates updates and upgrades, because all the objects that you onboard, all the solution elements that you onboard are going to be version controlled. You can anticipate that they're going to change over time as different partners and vendors, et cetera, update their service endpoints or their application code, or you update a technology somewhere or change a protocol. When it's time to update that, you just go back to that object, you update it, version controlling it, we'll take the new information, we'll collect that new information, and yet we'll also preserve the history so that we know all change to that object over time and who made those changes. So this is what Enterprise Web looks like as a platform, right? So we take that architecture, which I thought would be most familiar to many of you, given interest of the type of people who attend a CDW meeting. So we focus on the graph architecture, but essentially we're wrapping that with capabilities of an information system, right? There's, object modeling, as I just described. There's a design environment for declarative composition. So once we have objects, we can go to the catalog, declaratively compose objects into services, and then we can chain services into event-driven processes, all with no code, right? We're using the metadata and the relationships, domain semantics, as it were, from the graph knowledge base and the upper ontology to compose all of these things so that we can do them with no code. And of course, the system also offers a runtime, right? It's a cloud native, asynchronous, concurrent, so it's massively parallel, event-driven system. It's a reliable messaging, transaction guarantees, and state management, all again included. Just like we abstract the storage, we're actually abstracting a lot of the complexity of being cloud native itself, right? And this is a real struggle, even for advanced engineers, They're largely implementing these ideas like reliable messaging, transaction guarantees, and state management on a per solution basis. And here we're providing it on a platform basis. So it's available, just as that's something that everybody can rely on in the background. We're also wrapping it with platform services. Essentially, we're replacing, if you look at this and you'll see a lot of common terms here, things that you would expect in a common middleware stack, we're essentially replacing the middleware stack with a set of serverless patterns, right? Serverless middleware, that's what this really is. Instead of having different components, you each have to implement and then manually integrate, and then you have to write and code all your applications to the top. Here, Enterprise Web says, actually, no. Model everything declaratively, and then either the type system will attach behaviors in the background, or depending on the use case, you might need to specify a certain behavior, and then you can call these functions directly. But what you're getting is this very lightweight, low latency, high performance middleware that's all served up in a cloud native kind of way. So this is, our Enterprise Web Platform is subject to 15 awarded patents and is deployed around the world with a variety of industries from telecom to life sciences. Now I'm going to go to a concrete use case. It's an SAP use case. SAP is the world's largest enterprise software company, so I'm sure many of you are familiar with them, or if not, directly experienced with working for SAP. And of course, they have great products, but like with any large company offering a wide variety of solutions, whether that's Salesforce or Oracle or Amazon or Google, for that matter, it's not always easy to work across all of these, right? They weren't all architected together. They have discrete sets of tools and products, and often today we're not just connecting one vendor's products and services. We're actually connecting them with SAP and non-SAP endpoints. So this use case is going to explore that. So SAP customers nowadays, like I said, have to struggle confronted with an increasingly complex array of SAP and non-SAP endpoints. So they need to integrate, orchestrate, manage, and maintain across the set of them. Now, SAP has a lot of great assets, a lot of great development assets, right? They have this thing called the Graph API, which is the one domain model, the virtual data model. They have these config files called the IMG Spro. They've got a lot of great assets that we can leverage, but in and of themselves, those assets aren't fully connected, right? They lack the semantics to fully connect a solution in the kind of way that I'm describing to you. And solution delivery over SAP at this time still requires a mix of custom code, manual integration, BPMN workflow modeling, interface development, and complex configurations that are going to be done with a mix of model and code. And of course, the problem is once you've done a mix of model and code, the model's not driving everything. And that means that you're going to have these black holes where you don't know where things break, and you're not going to have end-to-end transparency. In distributed systems, you really want that. You want to know where things go wrong. You want to know how your services are being consumed. Right? You want to be able to analyze that for security. You want to analyze that for optimization. You want to make sure that your customers are having great experiences and that you're supporting your SLAs. So transparency is non-trivial. So let's look at a service, right? This is sort of in the process world, they would call something like this like a 3-byte kebab or a 5-byte kebab, which is this industry kind of jargon for describing a simplistic process. But there's going to be a third-party customer portal where somebody's going to order a cloud application, right? So this is going to be a cloud native or a digital business use case. Somebody's going to actually order something that is in effect a digital product, a cloud application, and the delivery will also then be a system delivery, right? We're not selling jeans or a car. We're selling something that's completely digital end to end. So, and then the delivery is going to be done over Google in this case. And so we're going to have a third-party product. We're going to have a third-party delivery system, but the ERP type services in between will all be SAP. So what we want is some sort of model to connect across those, because without that model, we're literally manually integrating it. That's all we have to do, and especially since these aren't all fully connected. Even the SAP products aren't fully connected by a model, and let alone connecting across the others. So instead of writing interfaces, doing manual integration, doing manual code, and then of course maintaining all of that, coding and recoding, integrating and reintegrating as things change, because if any one of these elements change, your solution breaks. We're going to do this all in a model. We're going to do this with Enterprise Web. So here now you see Enterprise Web over the top. It's providing the abstraction layer I described, the middleware services, right, called platform services, and the cloud native platform runtime. So It's not going to happen magically, right? We're going to leverage those SAP developer assets to begin with, right? So we're going to take those assets that I told you that were disconnected, and we're going to connect them. We're going to create one unified graph SAP domain, and we're going to do it in minutes, and we're going to then show it to you. And we don't have to throw away assets. That would be silly. We want to leverage those assets because they're good. Also, it streamlines and accelerates our solution delivery. So we'd be fools not to leverage the existing documentation and models that partners provide. So in this case, an solution architect can call these APIs, call this documentation. They're going to import them into the system. The system is going to do the entity extraction, and it's essentially going to set up that initial graph knowledge base, right? It's going to set up your graph operational domain. It's going to generate a unified graph connected SAP domain model mapped to our upper ontology, just as I described. And by that mapping of the SAP domain, which by itself wouldn't be connected to the enterprise web upper ontology, it's being wrapped essentially in additional concepts, types, and policies, which enable the declarative composition and the intelligent orchestration. From there, now that we've onboarded the models, we're going to onboard these objects, right? We're going to onboard these domain objects, which is the services themselves. Now, at some level already, since we have graph knowledge base, and when we imported the SAP assets, we learned about their objects, their interfaces, their properties and behaviors. We're already going to be able to generate a lot of this information here as far as these three services are concerned. So even a lot of that work is going to be done. We're even going to generate configs and things for these out of the documentation that was provided by SAP. So again, we're always seeking to leverage things that exist so that we're going to accelerate solution delivery and then put people in this sort of very agile graph domain model. And the last step in this case was, because we also talked about processes. Now, we could model from scratch in Enterprise Web a process. It's essentially in Enterprise Web, processes are data flows. A data flow, actually, by the way, is a graph, right? It's a natural graph, right? In Enterprise Web, a process, the definition of a process, is a set of tasks with relationships to events and policies. So the tasks then bind. It's not a static flow chart. The tasks bind based on conditions, which is very exciting. It allows you to have really creative policy-based processes, event-driven processes that can respond to a lot of variance, a lot of what you would call in a traditional flowchart exception paths, which become very difficult to maintain. We make that much easier. In this case, actually, though, we're just going to import. SAP actually had a log called action logs. We're going to import the action log, extract the workflow logic, we're going to map it back up to the objects in the model, generate an event-driven data flow process with all the service integration points and the corresponding UIs completed out of the box on import within seconds. Again, leveraging assets to great effect to accelerate solution delivery. You could do everything manually in Enterprise Web, but where you have assets, leverage them. The point here, at its core, Enterprise Web is a no-code integration and automation platform. It's completely open for federation and extension. So we're creating this environment so that you can onboard whatever you need to onboard into the domain as you describe it. And we're just trying to make it easy for you to have that domain and use and share that metadata. We're going to I'm going to pass the baton here into a demo. And in a second, my colleague Bill is a chief system architect. He's going to provide the demo. He's going to do that use case that I just described. He's essentially going to walk it backwards. He's going to show you the process that we generated. He's going to run the process, which will be a mix of system steps. Then he's going to drill into the process tasks, and he's going to show you how it was connected by metadata. You're going to see the objects being referenced. He's going to click into an object. You're going to see all of that metadata. You're going to see how that object is mapped up to the knowledge base, to the SAP domain. You're going to see how the SAP domain is actually mapped up to the upper ontology, and you're going to literally be able to walk that graph seamlessly. If you had the right permissions, you could just do that, as Bill can, and we'll do that in the demo. So I hope you enjoyed the demo. I hope you enjoyed the presentation. Thank you very much and have a great day.
I'm Bill Malik from Enterprise Web. I'm going to be walking you through the demo. I'm going to work backwards. I'm going to show you the actual running use case to start, and then drill into some of the logs and sequence diagrams and other sort of backing materials that show you what happened in the process. And then the second half of the demo, I'm going to drive into the models that make all the automation you're going to see possible. So I'm going to start out, I'm logged into Enterprise Web and I'm looking at the process flow for this use case. Now the use case was a digital business scenario that went from a customer actually ordering a cloud-based application right through to us dynamically deploying that application for their use. This order to fulfillment use case was actually mined from SAP logs. We use that to extract the workflow logic and generate an event-driven data flow process. So what you see here isn't a traditional flowchart. It's actually a graph of tasks that are connected by events and policies. And if we went a step further here, each of the tasks that you see, all the human and system tasks that are actually in this graph, all the content for them was actually generated using models, files, and other artifacts that were shared by SAP Labs. And then to finish it is actually access to their public SAP APIs. So we were able to even generate things like the integrations that would need to be taking place behind these tasks. And the important part is this entire process was generated with zero code and zero manual integration. So to start, since this is a digital business scenario, I'm just going to pop into an unused Kubernetes node. This is where we're actually going to deploy the cloud app at the end to show you that this is real. So you can see right now all we have is the Kubernetes service running. We'll come back to this in a moment. So now let's execute the process. This is a third-party customer portal. It could be SAP, it could be Salesforce, or any other CRM that you can automatically integrate with our system to provide the sort of front ends. Or in this case, we're actually generating a simple UI based on a package of HTML and JavaScript that was shared to us by the SAP Labs. So we're generating all the bindings, dynamic logic, and other things that go along with this form. So I'm ordering the application, and it's a pretty simple little process. This will create the requisition and kick off all the messaging to the SAP services that underlie this and advance that workflow that we saw earlier. There's a second task in the workflow now, so a second UI. So I'll just pop into that. And basically for this UI, it's just very simple. I'm going to be routing and adding some new details onto the service. In this case, I'm going to indicate that Enterprise Web is actually going to be the one who fulfills this digital business scenario. I'm going to pick Homebridge as the application that I want to order from the cloud, and I'm going to go ahead and create that order. Now, if I pop back into Kubernetes, you'll see it deploying here. So within a couple of seconds here, we actually have that full delivered and assured application. The user could even go ahead and actually start to use it now if they wanted to, log in and take advantage. All that happened in a couple of seconds. Now, what I'm going to do is actually go back a step and show you what happened in those couple of seconds, what the interaction looked like between the different services that were involved. Okay, so what we see here in Enterprise Web is actually a sequence diagram that was generated to show the interconnections between the SAP and non-SAP services. So you can see our third-party portal that we were just working with a moment ago, the three SAP services that sort of underlie this, ordering, requisition, and fulfillment, and then finally the actual provider of the, in this case, a cloud-based application, which was Enterprise Web. And what happens is there's quite an interaction of messages at a high level between these different participating parties. The point, though, and really the benefit here of Enterprise Web is that it handles all of the, if you want, all the operations that need to go on between each one of these messages. In a normal application, these are long, highly engineered kinds of integrations between the parties who are taking part in the process. We do all of the integration here and all the guarantees and other things that are needed, whether it's protocol translation, modification of, say, an object, or translation between an order object and a requisition object. All of that is done for free by Enterprise Web as a result of all the modeling that's on board. So we get this kind of a process, if you want, just generated from Enterprise Web based on the metadata that we've already collected. Now, we can actually go a level deeper here and drill in on what the events are that are behind this if we go to the Enterprise Web logs. So I'm back in the Enterprise Web portal, And what I'm seeing right here is actually a materialized transaction object that covers the span of all the lower level details you just saw in that sequence diagram and in the instance of the process we ran earlier. If we want to, we can drill down right to the detail level, and we can actually see every single step that was taken. And because we have a unified SAP domain connected on the top, we have complete transparency. We can see everything from a particular northbound interface that may have been worked with, translations between things like JSON and OData, and so on. And the importance is that we can actually trace this down right to the individual steps that are involved. So this gives management the ability to query real-time state for any process and get a complete audit history. And then IT can use this to trace any of their troubleshooting. But most importantly here, I mentioned it a little bit earlier, is that if any step in this process would have failed, the system would have recorded that incident and provided any compensations. So this is where you would have seen things like callbacks, circuit breakers, kinds of escalation paths, rollbacks, etc. if they're required. The system is giving us an actual guaranteed transaction here. That's what's being implemented, and we here have visibility into the lower level details. So in summary, what we have here is an asynchronous concurrent event-driven process with state management, reliable messaging, and transaction guarantees. Okay, so now I'm going to transition into the second half of the demo. What we're going to do is we're going to take one of those tasks that you saw in the original process map, and we're going to drill into it and show how we can walk from the metadata that describes that task up to the connected SAP objects, from those connected SAP objects up to the SAP domain, and then finally how we extend that domain with Enterprise Web concepts, types, and policies to make this a fully programmable graph, and really how we're able to make all of the no-code integration and implementation you saw earlier possible. So I'm back in Enterprise Web, and this was the process flow or graph of tasks that we saw earlier. I can click on any one of these and actually drill into the details and description. So here we have the convert requisition to order task. There's a number of details here that we could go into. Basically for a task, we have preconditions, the actual function that gets executed, and any post conditions. This is for a system task. We don't have any preconditions in this case, and we have a couple of post conditions, so a couple of next events, if you want to call it that, that we've built simple policies into to determine the routing. Now, the thing that we are concerned most about in this kind of a case is actually looking at the trace down to the SAP objects that are underneath. So when we did all of the event log extraction, this is what the system was able to infer from those assets, that this actual process was a transformation between services. Some of the lower level details, like the fact that it's OData and JSON, will get pulled eventually out of the SAP graph that's underneath this. So that's just nice for us as a, sort of playing the role of a developer or a modeler or process engineer on the other side. We can always go into the actual details that the system used to pull this info, which happens to be one of the SAP endpoints. So we can see it here in the Business Hub. They just call it a VDM. It just happens to be a description of the concrete REST endpoints and the sort of concrete schemas that were underneath. All of this was imported by Enterprise Web for free and is used as the sort of underlying data for translating these objects. And if we go a little bit lower, we'll actually see the graph of where one of what they call an ODM concept, just basically a business level concept, starts to connect to things like that purchase to requisition endpoint that we just saw a moment ago, the concrete APIs. So now if I was permissioned, I could actually walk back into the metadata references for the SAP domain and see how this starts to map up. So what I'm going to do is actually I'm just going to go ahead and jump into another system where we have those permissions. So now I'm in what we call the model manager. It's just another component that's used by someone like an architect to take a deeper look at and manage the models that drive these automations. We can see that same object that we were just looking at a moment ago, the order requisition. So this is sort of a business level concept, and we can see how it's connected with other business level concepts like organizations, sales orgs, country codes, etc. So we get the kind of business context that's been modeled in Enterprise Web based on the SAP objects. And then we start to see some things that are a little different up here on the left. We can see this purchase requisition endpoint, so an actual concrete service that was used for placing these orders. And then you can see the actual SAP endpoints that we talked about in the the use case itself. We've been talking about requisition, fulfillment, and so on services before. So if I want to start to get an idea of how Enterprise Web actually implements something like this requisition service, I can click on it and the system's going to recenter the graph around it, and I'm going to get a lot more information. What I can see here is actually some SAP type concepts. You can see things like their actual ordering service here, and I can, of course, retrace on that. I can walk through this in any way I want, but when I'm looking at one of these components, what I'll see is a couple of things that are actually interesting. All these blue nodes are concepts and, in this case, actual implementations that have been imported from Enterprise Web. So they've been mapped across, and they will sort of automatically kick in when I want to use something like this ordering service. So it has properties like event logging that aren't really native to this REST API, but we're actually, if you want, wrapping that API with these kind of additional value-added services. Things like the protocol translations and so on, transformations that we talked about earlier, are all part of this graph. And really that automation, if you want, it's walking this graph. When it needs to use the ordering service, it walks down this graph to find out what implementations we might have in Enterprise Web, is sort of filling in those blanks for us. If I go even a step deeper here, and I actually want to see how the Enterprise Web types and policies kick in, I can go a little lower here. I can see that that ordering service was implemented by an entity. In Enterprise Web, there are things like processes that are possible, and there's also this thing called a virtual function package that's attached to it. And basically, this is an object model that makes that service completely executable. You can see all kinds of details about it, whether they're types, formats that you're probably used to. OData happens to be the current one used here, but you can see that it makes possible things like converting it to Yang automatically, to put into a third-party service. All those kind of low-level details that take developers a long time to do, we're taking care of for free, all based on this kind of object graph that we put over each one of the objects in the SAP domain. And this is really, at the end of the day, what makes this programmable. This is something that now can be consumed by a developer through an API, used directly in the user interface for modeling, or even exposed to AI, so that value-added processing can be injected into the system from a third party. So that's the end-to-end demonstration. Thank you very much.